Route 53, DNS management made easy. Gotta love Amazon's creative naming on this stuff. Just so happens that DNS uses UDP port 53 and the mystery is exposed. So let's talk about what this is all about. We're moving into the next product in the AWS suite of offerings that Amazon is giving us. So why do we want to use DNS from Amazon? What makes it better, or is it better? I mean, it's going to cost us a little more money to do this. Why do this? So we'll explore that. Then we'll walk through the interface. It's a very simple interface. It's very similar to S3, very straightforward on how to do it. But then there's some features that you may not know about. So we'll look into setting up Route 53 DNS and then understanding some of the load balancing options. So before we dive into the specifics of the AWS Route 53, let's talk about DNS in general, as in what is it? I mean, we live in a highly technical world where things are dealing with IP addresses and MAC addresses and bits going across wires all around the world, billions of bits every single second, but our users don't care. They want their Facebook. They want their Google, their CBT nuggets. They want to make it simple to put in a name, and then that just does what they need it to do. And that's what DNS is there for. It's a service running on a server somewhere that takes names, we'll say, cbtnuggets.com, and translates it, if I could write and talk at the same time, translates it over to what IP address that actually maps out to. So now whatever device requested that says, oh, okay, I go to that IP address and request cbtnuggets.com, and I am good to go. Now the device will actually cache that information for a certain time, and that is known as the DNS entry time to live. So that way, every single time you click a button on the website, it doesn't have to say, now what was that again? What? Come again? Huh? What? I mean, it'll cache it for however much time is specified. A lot of times by default is 24 hours, but you can specify lower if you'd like to. But that, I mean, already think of some of the considerations. If I've got a website running on a server out here, and I say, oh, I want to replace that server. I want to, it was 170.1.1.1.1, and I want to use .2. Well, there's all kinds of people that have that 170.1.1.1 cache. So when you make that change in DNS, people may still be using the cached version of that for quite some time, accessing the old server. So that's the flyby overview of what DNS is. It uses port UDP 53. So when this client asks for a domain name, it doesn't have to create a TCP session of SYN-ACK, the little three-way handshake of TCP, and nothing like that. With UDP, it says, what's this? Okay, there it is. That's his acknowledgement. Is when he gets the reply back, he goes, okay, I got it, so I don't have to ask again. So now let's get into, yeah, that's what I was going to do. I was saying, well, why did I have that command prompt open? I was going to show you something. So NSLookup is my lifelong DNS tester utility, and 4.2.2.2 is my lifelong love of a DNS server out on the west coast of the United States in California. So that's an open DNS server that anybody could use. So if you're bored and you just want to check stuff out, you can go to cbtnuggets.com. You can say, okay, well, CBT Nuggets is actually 23.23.235.60 or Amazon.com. And Amazon.com comes back and goes, oh, there's actually multiple IP address. So what our browser does in that case is try the first one first, and if that's not available, go to the next one, the next one. It's kind of like a redundant DNS in case one of those are down. I can even change servers. I could say server 8.8.8.8.8.8. And I could say, give me Microsoft.com. Comes back with those answers. Now, everything that I'm looking up here is A records. Those are considered aliases, and that's the norm. Like, I create an alias. cbtnuggets.com really goes to this IP address. It's an A record. But there are many different types of DNS records that are out there. For example, when somebody's trying to send you email, they're actually going to send you a message to your MX record, meaning they're going to look up your MX record. So let's say I want to say set type equals MX, and let's look at Microsoft.com. So I want to find out who is Microsoft's mail server. Well, it's actually mail.messaging.microsoft.com. So then, whatever email was trying to be sent would do an A record lookup and say, well, what IP address is mail.messaging.microsoft.com, and then send that email in that direction. So all kinds of different DNS records that are available. We can always check them out using NSLookup. Now let's get into the Amazon specifics. Okay, so you go to your domain registrar. Let's say it's Bluehost or domain registrar. I hate to make assumptions. You have an idea. I want to build a company. What was the thing? Ephemeral Life. I want my Ephemeral Life online game. So I go to a registrar to register the domain name Ephemeral. I gotta pick names. The EPH Life is my domain name. .com is what I want to register. So I go to a registrar like Bluehost or GoDaddy or the list goes on. And Network Solutions. There's all kinds of different registrars out there and register this. And a lot of times they're gonna try and rope you in. They'll be like, hey, you know what? For $5 a year, or sign up for a hosting account, or even a lot of times at no extra charge because they wanna suck you in to their other services. They'll say we'll host your DNS. So they'll give you access typically to a little cPanel, unless you use GoDaddy, and they'll bury it in all this marketing that they try and sell you 500 things on the way to a DNS control panel that you have to dig for 15 minutes to find, and then you finally find it, and it's just painful. So outside of that, most people use cPanel, which allows me to say, well, I want Ephemeral Life to actually go to my EC2 instance at 70.1.1.1.1. And fill that in. And I want www.ephemerallife to actually go to an informational page of 180.1.1.1. And I want mail. You get my idea. You start setting up all your records there because it was included, or it was only $5 a year, or I previously hosted my website at Network Solutions, so I figured why not use their DNS? Well, let's look at this list of bullets that I created. Bam! Number one right there. DNS server failures can cause complete system failures. So often, something that it's easy to forget. If this DNS server, who knows what that's running? You registered your domain there, great, but who knows what that little cPanel DNS server is running on? Could be just a little podunk Linux box shoved in a rack somewhere at somebody's house. We don't know. Nobody really, very few people, I should say, publish their DNS information of where those servers are actually at. So if that goes down, everything goes with it, because nobody, think of the tech support calls. Oh, well, yes, no, you can't access us using cbtnuggets.com anymore. Please go to a browser and type in 180.1. You're done. Nobody's going to do that kind of thing. So that's a major thing that is often overlooked because people just don't think about it. It's easy to miss. Also, DNS server latency can make your whole screaming fast system that you're paying for these mega-sized EC2 instances still feel slow and clunky. Because when I don't know if you ever gone to a website before. Let's say you bring up a web browser and you go to, let me see if I can think of maybe Nissan. NissanUSA.com. Down at the bottom, it was too fast. I need a slow website. www.slowwebsite.com. It's got to be something, right? Go figure. So anyway, at the bottom, you always see these little, loading, waiting for. Oh, here's a good one, MSN. So MSN, you can see loading, waiting for Facebook. Right there, waiting. You see that? Waiting for. I'm trying to lower left corner. Everybody's like, where? Huh? What? Huh? No, in the lower left corner, you see all these little waiting for, all this kind of stuff. Those are the DNS requests. If you've got a really slow DNS server, then somebody's going to be going to your screaming EC2 instance, but they hit there and they're waiting, and all of a sudden it comes back and goes, oh yeah, it's over here, and boom, your website appears. But within that website, you also had maybe this image which came from images, so there has to be another lookup, waiting, and then poof, that image appears. Because your server's running really fast, but the DNS server can slow your whole system down. So with AWS, you are guaranteed a just amazing DNS platform. Just go to Amazon's website and get the feel for it. You click, bam, bam, it's just showing up everywhere really quick. Now, most DNS services providers are not distributed and have little documentation on their system. We live in the world. Yes, that's what it is. Over here in South America are users that have to go to their ISP to access their different websites. And if you're using a DNS hosting provider that has a little server up here, well, they have to travel all the way up here to New Mexico to get a response back to say, oh, this is the IP address. So many DNS providers aren't distributed, meaning they don't have DNS servers all over the place, whereas Amazon does, and they fully document where they are. Now, I'm not saying, oh yeah, DNS providers other than AWS are going to really. I mean, take GoDaddy; they're huge. They're a big provider. They have DNS servers around the world. I know, at least in the United States. I know in Europe, but you can't really ask them. Well, where are all of those? Very few providers really bother to tell you because most people don't ask. But AWS sends it all over the place. Multiple load balancing options. And actually, I'll just say that. We'll talk about that in a moment. Route 53 API, meaning there is actually an application programming interface to allow changes to Route 53. That's pretty cool. So what you could do is, come up with a service. Again, think of Ephemeral Life is my case study, right? So let's just go with that. Maybe when somebody signs up for Ephemeral Life, they get their own little personal, like jeremy.ephemerallife.com player page that gets created automatically. So I could configure my EC2 server instance or whatever I'm running Ephemeral Life on to automatically go create an entry in the DNS table at Route 53 for jeremy.ephemerallife.com and point it to the right servers and all that as that account sign up happens. I don't have to have any manual involvement because it's all automated using that API, and that's well documented. You can use it. And then, of course, my final statement is, good grief, you're using AWS for everything else at this point. Why not? Let's just consolidate all our services into one place. So let's get into the configuration of DNS. So the first things first is Route 53 is accessed just like everything else in the management console. You can see it right under the compute and networking section, Route 53. Now, before you can start using this, and I want to talk about the pricing as well, show you a little of that. But before you can start using this, you do need to point your registrar to this, meaning wherever you've registered your domain name. And get back to my whiteboard. So let's say I go to Bluehost. And I say, I want to register my ephemerallife.com. And that is now registered, known at Bluehost. So they've kind of been your registrar for that domain. So now I'm going to take that in there, and they'll have a little control panel saying, who is the DNS for that? By default, it's probably going to be pointed right back at Bluehost because they're going to be, the DNS by default. But you need to point that over to the AWS servers. Now, how do you know what those are? Well, it'll tell you once you add a zone in here. So you can add any hosted zone that you want, whether you own it or not. So actually, before I go into it, let's talk about pricing. Let's see. They have a quick link on here. Amazon charges essentially 50 cents a month. Let's see if find pricing. Price. There we go. 50 cents a month. For each hosted zone that you put in there, for the first 25 hosted zones, and then 10 cents a month for each additional hosted zone. So, relatively inexpensive. I know some people who are extreme penny pinchers are like, well, my hosting provider does it for free. Well, sure. I mean, you're probably paying that hosting provider something per month. They're probably wherever you registered that zone. But for 50 cents a month per domain, or 10 cents if you go above 25, it's nominal. Then you're going to pay 50 cents per month per million queries for the first billion queries per month, and then 25 cents for each per million queries for each additional. So essentially, to host, let me just say it this way. To host a zone with Amazon for a normal zone, it's going to be $1 a month. You're going to pay 50 cents to host the zone there, and then you're going to pay 50 cents if as soon as somebody tries to look up what IP address or do some name resolution on that zone. Now, 1 million queries is a decent amount. I mean, you've got to have a pretty lively zone to exceed 1 million queries. So yeah, so again, nominal. We're looking at nominal charges, and it's funny. I was thinking about putting together just one of the things one of the things that we do at CBT Nuggets is put these micro nuggets together, which are just little 5 minute or less, super action packed kind of topics. And I was thinking of doing a micro nugget on how to host a website with AWS for $1 a month. And I was thinking of showing people how to register for a free account. For you get 5 gigs free for a year on S3, right? So S3 is quote unquote free. Then the $1 a month will be just Route 53 when we set up DNS resolution, and I can even say in there that's optional. So it might be a fun topic to do. So let's do it. I'm going to create a hosted zone. Oh, and one thing I should mention. Pay for what you use. Do they have it on here? Ah, look at this. To allow testing, hosted zone delegated within 12 hours is not charged. So if you want to kick the tires on this thing, Amazon's like, hey, you got 12 hours. We are not charging you a thing. So let's. So this nugget will be 11 hours, 59 minutes. So I'm going to click create hosted zone, and let's say I was doing one for nuggetlab.com, and we'll do CBT Nuggets lab files. Man, that would be a cool series to create. AWS Labs, where I just kind of have certain tasks. So there we go. Here's our delegation set. This is what you want to point all of your name servers to. So go to your registrar, bluehost.com or whomever, and you're going to say for DNS, go to 1, 2, 3, 4, those 4 names that you see there in that list. And now, anytime a lookup comes in, it's all going to be pointed here to AWS DNS servers. So we've got Nugget Lab. It's now ready. It's set to go. I'm going to go to the record sets. So now we're seeing the actual records for nuggetlab.com. Now, 2 records are created by default. The name server records, saying these are the name servers that own nuggetlab.com. And then we have a start of authority, SOA. The SOA is, this is the server that essentially began. This is the primary server, if you will, for that zone. But I can go over here and create whatever additional records I'd like to. For example, let's create the most common one. I'll click on Create Record Set. On the right-hand side, it's saying, okay, what alias record? You can see the type is A, IPv4 address. What A record would you like to add to nuggetlab.com? So that's where I would say, www maybe is a record that I would have. What is the time to live on this? You can see by default it's 300 seconds. So it'll be what, 5 minutes? 5 minutes by default. So we can say, you know what, I want to increase that time to live. Now, again, a reminder, what is that? That means when a client gets, www.cbtnuggets.com, attached to that record will be the time to live, and they will cache it for whatever time you've specified, so they won't keep coming back and hitting the DNS server. It allows them to have faster access to that. But for a very dynamic site, maybe you're changing very often, you're doing load balancing, those kind of things, you might want to say, well, I want to drop it down, to a very small time to live. Now, the client can override you. They can put policies on that says, no. Ignore what they're telling you is the time to live, but very few people do that. So you can even have it go for a day or beyond. So whatever time to live you'd like to. Now we type in the IP addresses. So if you have more than one address, you remember when we did the NS lookup and we saw for some of the sites there was more than one address that it's using for redundancy, you can put those in here. So I'm going to say www.nuggetlab.com is actually going, let's make it real. Ping. I got this computer from CBT Nuggets. This is the most amazing. Hang on, I got to show this to you. Look at this thing. Oh my word. I'm going to properties on this. Windows 7 Professional, 16 gigs of RAM, i7 37.7 CPU, 3.4. It's just like, this is a meaty machine. And so I was like, this is great. And the most disturbing thing is I opened the command prompt and it says trainer 2. And my initial thought was, who's trainer 1? that sounded totally wrong. Like, well, where am I in that list? But anyway, I was just curious. So nuggetlab.com is currently going to 107.20. Let's turn on quick edit. Oh, it's there. So I can just go shoop, right click, and paste that guy right in there. So put that in there. Enter whatever number of records you want and create. And just like that, we now have our first A record for NuggetLab.com. And you get the idea. We can go through and keep adding Jeremy, and we'll point it to the same place, create, and so we can add whatever A records we want into this list. Now I'm going to click on create record set and also mention that there is just all the different records that we can create. For instance, a C name, conical name, which is just like an alias. So I might say images.nuggetlab.com really points to images.nuggetlab.com what would it be? East, Amazon, whatever, AWS. Remember, I'm pulling this from what Nugget? The last Nugget, S3, where we hosted the website. So we can create our CNAME record that goes out there. So there's this is a full DNS server, so we can create every major record type that we would want. A mail exchange server, so we can put in where our email should go. So all of the core DNS functions, and I really don't want to dive into let's break down DNS and all the features that it has. I just want to show you how to implement it on AWS. So all of that is there. Now let's start looking at some of the AWS specifics that you get that other DNS servers don't give you. First off, let me get off the MX record and go back to the A record. One thing that I passed up when I first was talking about it was this alias. Alias allows you to do it'll let you do two things. One, you can do almost like a quick CNAME without creating a CNAME. So maybe I want to create, web.nuggetlab.com actually points to www. Well, I can click this little drop down and it automatically comes up there and says, hey, I'll give you kind of a quick link. So nothing really special there, just kind of a quick way to create aliases for your existing DNS records, which is nice. But let me show you where I think this is going to get neat. Oh, don't hit backspace there. You don't want to do that. Whatever you do, don't hit backspace. I don't know what I just did there. All right, so let me get back in there. Create a record set. We're going to go web.nuggetlab.com, go back to the aliases. When I click this drop down, I can see the record sets in the hosted zone, but also look right here, elastic load balancers. To where if I have elastic load balancers, take your brain all the way back to the EC2 world, where we were talking about the elastic load balancers being available to you gotta hang with me. My brain is a little scattered, and I just started wearing glasses. I've started reaching that age where I'm staring with glasses, and I just went to adjust my headset that I'm talking, and my ear is in pain because I have glasses under my ears, and the little muff on the headset is just squishing my ear into the little bar on the glasses, and I just touched my ear, and I'm like, that's this is welcome to IT, right? We're like, oh, my ear hurts. Meanwhile, there's somebody who just dropped a brick on their foot, and it just almost severed a few toes, and my ear it hurts. So anyway, elastic load balancers, I can come in here, and if I have them created for my region, automatically just create a resource record, an A record that goes boom right over there to the elastic load balance cluster. Now again, is that something that we could create an A record, figure out the elastic IP of the elastic load balancer, and then add it in there as well. Amazon, that's why they're just trying to make it quick and easy for you. And I can totally see this expanding. Because as you click this in the future, my thought is we'll see elastic IPs and see all the elastic IPs, elastic load balancers, all the elastic load balancers. Essentially, a quick drop down of many different resources that we can. That's my theory anyway. So that's one piece. Okay, let's talk now about some of the load balancing features. They have routing policy down here, but I would say that should be called load balancing policy. Because that's really all this does. It says, number one, you can use simple load balancing, which any DNS server can do. And that's where you use, I'll just grab these guys, toss a couple IP addresses in for your DNS record. And the DNS server will, by default, start round robining. So the first person that asks for that DNS record for web.nuggetlab.com will get that, and then the next person that asks will get that. It'll start, kind of flipping through all the IP addresses that you have here, which is great. That's a nice little round robin load balancing that it gives you. But Anything can do that. That's normal DNS. Let's step it up and look at some of these other policies like weighted. Weighted allows me to do a little bit of unequal load balancing between them. Like maybe this guy is my beefy server. That's the EC2, mother of all instances server. I'm going to give him a weight of, let's see, what's the best way to do this? Let's say a weight of 5. Right now, this is very relative. We'll talk about it in just a second. Let me create a couple, and then it'll make sense. So I'll just say beefy web server EC2. Create the record set. So now I've got, you can see it's added in there with this little weight of 5 beefy web servers. So let's now add another one. I'm going to create a second entry for web.nuggetlab.com. We'll paste that in, change it by 1. I'll say weighted, and now the weight on this guy will be, let's say, 3. Set ID, we'll say this is a moderate web server. I'm totally using bad numbers for this. Let me see if I can. Well, let's do this. I'll say this is a 2. We'll go light web server. Create record set. And then, so 5 plus 2 is 7. And now I'll go in here. You see where I'm going with this? So I'm going to do a web, same thing. So a bunch of duplicate entries, which is not normal for DNS. Paste that in there. We'll say this one goes to this guy, and we'll say this guy is a weight of 3. I'm just trying to get the math right, so we got some nice values we can use. And we'll say this is a moderate web server. You see where this is going, right? So now what will happen is AWS will do weighted load balancing. So essentially 50% of the requests, the DNS requests, will end up going to our beefy web server. 20% will be going to the light web server, and 30% will be going to the moderate, giving us a total of 100%. That's why I wanted to land at 10, is just so that that numbers work out. Now you can use whatever values you want for those. You could say, beefy is 100, light is, 20, whatever. But it's a percentage. So just think of it as whatever values I use should add up to something meaningful instead of just being random numbers that I'm throwing out there. So that's pretty neat. So that's a bonus. So let me go to create a record set. Let's go Web 2. Now we've got paste in my IP address here. Latency load balancing. What latency load balancing does is actually measure the latency of your IP addresses based on the region or the location the person is requesting it from. Don't actually, you know what? You're probably like, oh, I need to hear that again. Don't. That was probably the worst possible way I could say that. Let me go to the whiteboard. That was one of those things I say that I was like, I think I just confused myself with that explanation of it. Let's go to Jeremy's cryptic drawing of the world, or steak and eggs, or Alice Cooper, or whatever you want to call it. So we've got the world, things all over the world that are requesting these. What we can do is we can create, now first of all, let me back up. Latency DNS record sets, let me jump back to the browser. Latency DNS record sets only work if you have EC2 servers, kind of like duplicated EC2 servers in multiple regions. So if that is not you, immediately, skip this. That's not something you have to worry about. But let's say you've got an EC2 farm over here. For some web servers. You got an EC2 farm over here for some web server. You got these EC2 farms all over the place that are essentially replicas, duplicates of each other, because you really want to be able to service your clients with the best possible way. So what happens is when a client makes a request, so we've got a client in Canada up here who says, I need to go to a DNS server, which is going to be AWS, to find out what IP address to get to www.eflife.com. Because Ephemeral Life has now expanded to where it's gone worldwide. So that hits the AWS server. What AWS does is look at the source IP address of where that person is coming from and refer to a table of data. Yep, Amazon is always measuring this. A table of data that says, okay, what is the latency from from that IP address over to our east region over there. Okay, it's I don't know 50 milliseconds. Okay, what is the latency to the west region? 75 milliseconds. Okay, it looks like the east region is lower. Thus, I will deliver the IP address for the east region. That's probably a much better explanation than what I was telling you on the other when we were looking at the slide. So what it does is based on wherever that person is, it will say, okay, your latency to this one is this, and your latency to this one is this, because Amazon is always measuring, always creating. Now this is not. I know some of you are going, okay, really? This is not an on-the-fly thing. It's not like somebody asks and says, hey, what should I go to? And it's like, well, let's measure. Looks like to here you're getting, okay, let's check the. I mean, it's not like on-the-fly measurements. Otherwise, you'd be sitting there waiting forever for that DNS response. Instead, they have automated systems always measuring latency of major geographical regions all over the world to their different farms, and they just refer to a database table and say, oh, real quick, I can tell you that latency to this one is better. Now, that may change. I mean, maybe as time goes on, the latency from Russia over to San Francisco here is lower than it is to the East Coast. So at that point, they may get different DNS responses. So those are always being measured, and always being updated in the Amazon database. But that's the latency-based measurement. So same concept. You would just say, okay, I've got some servers in the West, and we'll just say this is my California servers. US West 1, there's their IP address, create record set. So I would just start adding in, again, duplicate entries for Web 2 for whatever regions, East 1, Northeast 1, all of these different regions that I have my EC2 servers in. And then they will automatically use latency-based load balancing. I don't have to do anything else because it's referring to the database table behind the scenes. So wrapping up AWS DNS, it's pretty awesome. Why would you use it? I mean, we hit the high points on that. You're not just getting a DNS server in California somewhere on your hosting provider. You're getting a worldwide mesh of DNS servers that are fully redundant, giving you amazing response times for one of the most overlooked and critical services that exists on the internet. If that DNS goes down, everything goes with it. So that's a big why on there. Setting it up, we saw that. The interface is just brilliantly simple. I mean, I've seen a lot of DNS, interfaces to where you've got like cPanel where you're scrolling down 5 pages just to find your right record, and they're all just kind of a big table list. And then you've got GoDaddy, which GoDaddy, the best way I can say it is it's just like if you can find it, it works pretty well. But you have to find it through all of the marketing that they're trying. It's like, where's my control panel now? I can't. It's like, how when you go shopping at a grocery store and they purposely, I don't know if you know this, they purposely move stuff around. Like all of my ketchup, the ketchup aisle just got moved over to by the deli, but it used to be with salsa and everything else. That's where the ketchup is. Why do they do that? Well, because it's proven by people that if you walk around a supermarket longer, you're going to buy more stuff. And GoDaddy uses like supermarket logic on there. They're like, let's hide their control panel. so they have to go find it, and then they'll buy some more stuff from us. So you don't have to go find your DNS control panel with AWS. It's brilliantly simple. It's clean. It's fast. It works well. So finally, we looked at understanding the Route 53 load balancing. The 3 options: the simple, the weighted, and then the latency based. Put those together. That's Amazon DNS. Well, I hope this has been informative for you. I'd like to thank you for viewing.